Yeah, the first topic, first what we were discussing, that is latitudes. Okay, latitudes. Okay, so we were discussing about the latitudes. Okay, so here, so what we have done here, okay, again I'm writing degree. Yes, degree. And after that, name of the latitude, isn't it? Next is its significances are features. Okay, fine. So now tell me, the degree is 0, isn't it? Yes, the name of the latitude is equator. And what's the significance here? Our features. Tell me and what you have understood about it. Yeah. Yeah, and I can write, and before that, can I write here is the equator classifies Earth into two equal halves? Can I say? Yes, first you can say, okay, it cuts Earth into equal halves. Two equal halves. This is the first thing. And the second, as you told, and how many equinoxes? Okay, tell me what we have there, summer solstice or winter solstice or equinox? Equinox. And how many equinoxes usually we have? Yes, two equinoxes. Two equinoxes. Right? And the third important thing, okay, the two equinoxes means, what is the feature of this? Yeah, equal days. Yeah, the equal days and nights. You can write equal days and nights. Now tell me, can you get any wind here? Okay, now tell me, what are the ingredients we need to get a wind? Yeah, okay, we must have, that wind must have some density and it must have some velocity. Okay, horizontal movement. And if it has to be like that, and one more ingredient is there, right? And what is that ingredient usually? Pressure. There, okay, now tell me, there has to be a same pressure or there has to be a difference in pressure? Okay, that means what we can call the difference in pressure? That's fine, and we used a term. Force, very good. Right, pressure gradient force. Now tell me, if I say, if it has, okay, two equinoxes, now tell me what about the relatively the seasonal temperature? What might be the differences here? Maybe less or more? Equal. Because has an area or the region is experiencing more temperature in all of the season, somewhat same, okay, it is receiving the same temperature. If it is receiving the same temperature, so what about the temperature differences seasonally, relatively? The difference, less or more? Okay, fine. Now tell me, so relatively I am writing during June time, the sun is at? Sun is at? Northern hemisphere or southern hemisphere? Northern hemisphere. Okay, we can say that, exactly at what? Okay, yes, 23.5 degree north, you can say. Isn't it? 23.5 degree. And now tell me, and what about the temperature at equator relatively? Relatively, okay, just we can say, okay, relatively, and around 20 degrees Celsius. Relatively, you can say. Now, during the December time, the sun is at 23.5 degree at south. And maybe again temperature might be around 20 degrees Celsius at equator, isn't it? And now tell me what the thermal contrast, the difference. Thermal contrast means temperature difference. Relatively 0 means less or more it is. It is relatively less or negligible. Now tell me, can you get, okay, the temperature is somewhat relatively same. Okay, what about the pressure? Can you able to find any the pressure gradient over here? Is it possible to get? No, right? And if you won't get the pressure gradient force and it is, okay, now can you able to get that wind here? Is it possible for the wind to be generated, or is it the conducive environment for wind generation? No, right? That means what you can say, and this area is windness or windless? Windless. Yes, you can say it is windless. Windless. Why windless? You can write 1. Why it is windless? Because of the pressure gradient force is relatively less. Why this pressure gradient force is relatively less? Because the temperature contrast we have relatively less. Contrast in the sense difference. The difference in the temperature relatively we have less. So because of that reason, okay, this area is also sometimes called as doldrums. So what we can call them as doldrums. Getting my point? The doldrums in the sense is a condition with wind or without wind? Without wind. Simple sense. समझ में आ रहा है ना? Yes, why? Because it is windless. Why it is windless? There is no pressure gradient force. Fine. And one more thing you must know here, okay, some basics. Okay, before going or moving into the fourth topic or the feature, and some basics you must know. Already we have discussed the different varieties or different, okay, the modes of heat transfer, isn't it? Which are those? Conduction, convection, advection, good, and yes, radiation. So right, conduction, convection, radiation, advection. Okay, advection, fine, happens. Now tell me, and in the mode of heat transfer to the solid can be called as conduction. And on what base, okay, and how do you define convection? And if I want to say the convection, what must be required here? What is the required thing and what is the mode of heat there? Yes. Convection I'm asking. What is the mode here? Semi-solid or fluid. You can say semi-solid or fluid. Getting my point? Yes. Now tell me, what do you mean by current? What do you mean by current? Moving charged particle or anything moving in motion. Anything, if it is in motion, we can call it as current, right? Yes. And okay, those things already we knew. So what we don't know here, look, suppose just I am drawing this graph, okay, just to say it is temperature, right? So, okay, I am just here drawing in x-axis temperature. In the y-axis, I am drawing the state. What I am here, writing the state. Just already we knew it. Okay, what we already we knew. So, if, okay, it's a 2 only, okay, you can write as A. 1 the third. So, A and the third. Right? Suppose if I want to say, if temperature is relatively less, what might be the density in open system? Or relatively, okay, what might be the density of any matter? Okay, density would be high. Simple, right? And when you provide the temperature, automatic density will decrease or increase? Decrease. That's the thing we knew. Right? That means, can I write directly it has a solid? समझ में आ रहा है? Getting my point? Right? And if I'm writing, okay, relatively I'm increasing temperature, maybe the density can be reduced or can be decreased. If I provide density, what happens to the state? Yeah, decrease. That means maybe from solid to it can be liquid. Okay, or gases, whatever. Suppose again, still I'm increasing the temperature, and what about the density? Again, it will be very less. It can be decreased. And if it decreases means, can I say it can be what? Yes, gaseous. So think we understood. The same thing I'm writing here. Okay, write it's a 0 degree. Okay, 0 degree, and you can write 20 or whatever. I'm writing this, not exact the 20. I'm just giving here. Okay, a reference yesterday. You can write 30, you can write 40, and you can write like this. Right? Now compare 0 to 20 or 20 to 30. Okay, can I write directly here solid? Why I'm writing solid here? Maybe temperature relatively less. And if I'm increasing temperature, okay, you can write like this. समझ में आ रहा है ना? Getting right? And if the temperature is increasing, maybe state what it can do, okay, what it can be, it can be a liquid, right? You can write the same. If temperature even still it is increasing, the state would be again, yes, gaseous, right? You can write like this. So one thing from this, what we can conclude here is, right, just to say, if you are moving from here to here, right, if you are moving from here to here, right, what exactly is happening? Temperature is increasing, right? Temperature is increasing. And as we already, okay, you have learnt in chemistry, okay, any matter if it is changing from its state from solid to liquid can be called as liquefaction or evaporation, you can say, or liquefaction, you can say. From liquid to gaseous, you can say evaporation, isn't it? And if I say, okay, this is a 1. So one thing you must know, when the temperature you are increasing, the solid can be liquid, liquid can be gas, or sometimes directly solid to the gas. It can be possible. And similar way, okay, if you are moving from here to here, so here exactly what is happening here then? Here the temperature is, yes, decreasing. And here in this sense, okay, what is happening? Density is decreasing, and here is density is increasing. That's the phenomenon, the chemical phenomenon, you can say, the process which is increasing the density by decreasing temperature. Can be called as, can I write like this? Can I write directly like this? Condensation. One thing you must know, whenever temperature drops, there will be condensation. There will be condensation. Means, if the matter is at gaseous state, and it could be, if it condensation starts or embarks, it can be transformed into liquid. Okay. And if the liquid state matter, and if the condensation embarks, it can be again transformed or converted into solid. Like this you must know. Okay, understood. This is the first basic.